Okay, good afternoon to everyone that's coming back, and good morning to everyone dialing in from Brazil. Thank you for taking the time to do that. So just to get this webinar started, we're going to go through the items that we're going to cover today. So we're not going to do the full end of month process. We're going to create a studio survey project. We're going to set up a database for a demo project. We're going to define a few operational parameters. Then we'll run the end of month design and plan compliance reports. And we'll probably open at the end for I think 5 questions. So for those of you that were here last week, we had kind of like an open-ended arrangement where everyone had a question at their disposal and we tried to get to all of them, but that's not practical. So what we're going to encourage you to do is to ask questions using the dialog box that's at your disposal. With me this afternoon, or this morning for those of you in Brazil once again, is Haja Rahabat, a mining engineer, and she's going to be chipping in whenever she feels like.
Hello, everyone.
So just to do a bit of housekeeping, the video for this recording will be available after the webinar. And then, like I said earlier, feel free to ask questions in the dialog box that's available to you as we do this. And then the other thing that I would encourage you to do is register for next week's webinar. Next week's will be the final one, and a lot of the questions that will come up during this afternoon's webinar will be handled in next week's webinar, because next week we will be looking at the blast volume calculations. We'll also be looking at the stockpile management. So the stockpile management will go towards tailings dams, stockpiles, concentrate dumps, basically anything that you heap on surface. So today, what we will focus on is the following 3 reports that we'll look at. So the data sets that we're going to upload, first and foremost, will be to create the end of month volume calculation. We're going to set up the database, and then we'll run the software to generate this report, generate these plots, as well as the solids that you can then hand over to the geology department to take a look at. The other report that we're going to generate is the design compliance. Now, the design compliance is obviously a critical report that you can create, because this is where you're going to have yourself a detailed analysis for whether your operation is doing things in a safe and optimal manner. Safe in terms of creating the catch benches that will catch falling rocks, because that's one of the issues that tends to be missed out. And then optimal in terms of ensuring that all the ground that you've designed to be taken out has been taken out. So there's a various source of wrong mining that comes into play. You have deviation of pre-split holes, insufficient hole depths, errors in the blast pattern, and things like that. Maybe you've messed up your ring burden or the spacing in between the holes, or poor charging practices. Sometimes it can be a post-blast thing, like scaling improperly on the final pit walls. So what you want to do is to keep stock of all of those deviations from design in order to achieve profitability and productivity in a safe manner. The biggest thing, in my opinion, is how mining the benches as they've been designed contributes to ensuring that rock falls are controlled. The last report that we will be looking at is the compliance to plan. Now, in the context of studio survey, the plan and the design differ slightly. I'm not sure if you've got different terminologies that you use at your operations, but essentially the plan is what you want to achieve for the day. So at this point, I am going to open Studio Survey, and we will be looking at the software. So this is the welcome page that you will see the very first time you open Studio Survey. You're going to have a couple of, you won't have any of these, but you will have the tips as well as the welcome screen. So the first thing that we do is create a new project. Yep.
So the screen hasn't come to Morocco yet.
Oh, wow. Okay, let's just wait for a second. Let me take a step back. Let me know as soon as you can see it, Haja.
Okay.
Meanwhile, I will take your question, Erich.
Hello, how are you?
How are you doing? I can see your hand is up.
Can you hear me?
Yes, yes, we can hear you just fine.
All right, now I'm only seeing the, what is it? I'm only seeing the PowerPoint. I don't see the other screen.
Okay.
Maybe you can reshare again.
Okay, so let me reshare again. Are you able to see this? What could you just confirm for me what you can see?
No, I still see the PowerPoint presentation with the 6 slides.
Ah, I see. Okay, my bad.
Hello?
Yep. Thank you very much. Let's just fix that quickly.
The
What
other
about
thing,
now?
yeah, I can see your
Yes.
screen now. The other thing is just a question. I'm working underground. And from your PowerPoint, I see it looks like this is more from surface, open air, but
Okay.
you know,
Yes. So today's webinar is focusing on Studio Survey, which is our open pit solution. We can set up one for Amine in a couple of weeks, if that's okay.
But anyway, I'll just then it's fine. I'll just go because I don't know if I'll have any questions, but I'll let me just sit with you and yeah, we can go through it. It's fine.
All right. Thank you very much, Eric. You've helped us fix a technical issue. Appreciate it. Haja, which screen are you seeing?
Yes, exactly. Studio Survey. Please go on. Yes.
Okay. Okay, so what you're going to see when you open Studio Survey will be this screen. Let me just quickly create a new project. So when you create a new project, you're going to have this dialog box pop up, and then you can name it. So in this case, we're going to give it Webinar 2 as a project name. If you already have a directory there, the software will add any folders, any files that already exist. But in this case, we're creating a completely new project with no files in there. So we click next and we click next. So the window there will give you the parameters that apply to your project. So in this case, we just go finish. So first things first, we did have an overview last week, but I'll just go through it again. We have the Home tab, which is essentially a collection of tools that have been collected from the various tabs behind. But then in addition to that, you have your Import Survey, as well as your Add to Database and your Settings buttons, which enable you to essentially go through your workflow in as seamless a manner as possible. And then you've got your edit tab, which will help you to edit your strings, add strings, join strings, break strings, as well as activate some of the nifty snapping tools that we have in Survey. Then you have your surfaces manipulation one. So you can create digital terrain models, wireframes, you can clean and verify your wireframes, you can add, subtract in your surfaces tab. And then the reports tab is where we'll spend this afternoon. So this afternoon, we're going to look at generating your report on pit actual mining, doing your design compliance and your plan compliance. Next week, we'll be looking at your run of mine, as well as your blast volume calculator. And then you've got your data tab, which enables you to import, export, and manipulate your data set by adding, removing attributes, or manipulating your data sets with various expressions. And then you've got your format tab, which will have some pretty decent filters, as well as things like giving you the position of where your mouse is. So this is pretty cool, especially when you're querying data sets in terms of their geospatial locations. And then under system, you then have things that more advanced users would go like macros and scripting. And then also you can use this to customize your viewing tab. So for example, one of the things that I appreciate having here is my sheets bar. So I can use that to either hide or show the sheets tab. And then I can also collapse it. So that will pop out or it can remain docked. So for the first few minutes of our discussion, we'll have it docked and then we can have it collapse later on. So we'll go back to the home tab. So the first thing we're going to do is set up a database. Now, this is something that you would do at your operation when you're looking at essentially beginning to use Studio Survey and ensuring that it's set up for your periodic reporting. So like your month-end measure and your stockpile measures. So you can start by setting up your database. So we click settings and that dialog box pops up. So within this dialog box, we have the various things that can be customized. So in this case, we're going to create a location for our database to be initialized. So this location that we're setting up can be anywhere. You can actually put this on the network, which is actually what this is designed for. So you can go ahead. So in my case, I'll put it in the same location as my project, which is C database. We call this project webinar 2, and then make a new folder, which I'm going to call DB and say, okay. Oops, we can rename that here if you want. Database, yes. And then initialize. So you get that feedback that tells you that a series of subfolders have been created under the webinar 2 folder, and the software will manage your access to that folder. So to give you an indication of what that folder looks like, let me just browse to that location, drive C, database, webinar 2, and then we've got the folder called DB. And in there, the software has created subfolders for pits, which will have pits, areas, and the various data sets that will go in there. So as we begin to customize this, I'll be coming back to this folder to show you the changes that we're making as we progress. Okay, currently have no questions, so I'll proceed. Now remember, please feel free to ask a question whenever you see something that's a bit confusing or you need some clarification. So the first thing we're going to do is define our pits. So for the sake of this demo, we're only going to define one pit, primarily because of time. So you can define any number of pits. So in this case, we're just going to have one, and we will rename this pit Berry, B-E-R-R-Y. B-E-R-R-Y. If you have more than one pit, this is the same place that you're going to add any number of pits. So if your operation has 5 pits, you have berry pit, pit 1, pit 2, pit 3, and pit 4. But for the purpose of this exercise, we're focusing on only a single pit. And then this pit might be split into 2 areas, or 3 or 4, depending on your setup. So in this case, we're going to create 2 operational areas for this pit, and I will call one north, and then I will call the other one south by clicking rename and typing south. Now, there's different reasons for having different pit areas. So sometimes you might have a contractor in one area and a different contractor in the other. So when you run your operation in that manner, you can actually organize your pit by contractors or by mining blocks. It's entirely up to you. But what you need to basically have at the back of your head is these pit areas will be defined by the boundaries of the north and the south areas, or whatever you call them. So this is the definition of the pit areas in plan. And then we can go ahead and define the vertical aspects of this pit by going to manage to define our benches. So for the purposes of this exercise, we're going to put varying bench heights for each area. So in the north side, we're going to maybe give these a bench height of 10. I think that's okay. And then we'll put in the crest elevation of the pit, the bench height, and the number of benches. So we can have, well, at least I know the data set that we're using has 9 benches. So we'll put 10 in there just for the sake, 11 in there just for the sake of simplicity, and click add. So the software will go ahead and calculate the elevations of your crests and toes, and these will help us in our later analysis. So this has been defined to conform to the scope of the current area. The current area that we've got here is the north. So the moment you switch over to the south, you find that you have no bench definitions for the southern portion. So you can go ahead and do the exact same thing, but in this case, we'll just do something fancy. So let's say the bench height in the south is 5 meters. Maybe this is a contractor with smaller equipment, and the bench height that they manage is slightly smaller. So we'll go with that. We'll go with a 5 meter bench height, and we go add. So again, the software will calculate the heights and the crest, the elevations of the crest and toes. We're deliberately using the same crest elevation so that we have a uniformity in the reporting. So we say okay. So we now have a definition for the northern side, which has 10 meter bench heights. And we also have a definition for the southern portion, which has 5 meter bench heights and the respective toes and crests. We will come to the ROMs next week, but I can talk about them. So in the ROMs, essentially you can have anything that is heaped above ground. So you can have your tailings dams, you can have your stockpiles, your concentrate heaps, and essentially any dump that you want to keep track of, you can create for here. Studio Survey won't limit you to the number, but you can always do that here and beforehand. So we'll come to the ROMs next week. Please register for next week's webinar to take care of the ROMs. And then at the bottom, you can then create folders for your surveyors. So in here, you click Manage. And rename. So if I am a surveyor on that team, that will be my name over there. Say okay. And I can add Another surveyor can put Azure. Say okay. And then just for the kicks of it, I'll add Aaron as well. I can see here Aaron. So Aaron Muniz is the third surveyor on this team. So there we go. So what we've been doing as we've been editing these settings in these database settings, we've been making amendments to the folders that were there. So if you are paying attention, you will probably notice that initially this was called Pit 1. And if we come back to our DB folder, you're going to find that there's folders here that have been created for each of the surveyors that we've added, as well as the areas will have both the north and south. And then each of them will have a benches file, which when you open, you can see the bench definitions that we created for each one. Now, I need to mention that this benches file is exactly the same kind of bench file that is created in Studio OP. So if your operation, for example, has varying bench heights and you've got a file like that that was created in Studio OP, you can simply dump that file in this location and Studio Survey will read it, no problem, easy. Well, you don't even need to do anything to get Studio Survey to read it. The moment you have that file loaded, you can then see that the bench definitions have been imported. The other thing that you will have at your disposal are the various templates that have been already pre-configured. So Studio Survey, like we said last week, comes shipped with generic plot templates and generic Excel sheets. These are fully customizable to suit your operation, and you can change these to match your requirements. So we have some compliance, your plot templates for compliance, and so on. And then under the publishing, we've also got some templates that we can have in Excel. So if you in here, I've got two templates set up. So template 1 is if I'm going to use the natural topography to keep track of my progressive mining volumes. And then template 2 is if I want to essentially just compare previous versus current. So I can simply toggle between the two and have that. But the benefit of having the topo as part of your calculation is you have a check against your final volumes, because that's going to run through 3 calculations. It's going to take slightly longer, but it gives you more peace of mind. Okay, so moving on. We've set ourselves up with the mining area, the pit name, and the surveyors that are involved in this operation. So we can go ahead and say okay, and that will close that. The other thing that this does is it activates the survey import module, because now that we have somewhere to import to, I didn't show you this earlier, but without setting up a database location, you can't run the survey import module. Whereas in this case, you can go ahead and run this, which will enable you to download datasets from the instruments that you've got there. So for both GPS and total stations, you've got this quick tool that you can just plug your instrument to your computer and then straight away download a DBX or a GSI file from your total station, your GPS, and immediately have a DM file to work with. So exit that. Okay. So far, so good. We don't have any questions, so I will proceed. So in order to run our end of month module, I've got a folder that I've gone ahead and prepared datasets for. That's called Berry. We'll put that in the top corner over there. Let me just increase the size of that a bit. Okay, so maybe perhaps before I start pulling in my datasets, you're going to have questions with regards to, oh, where did these come from? So first things first, in the Sheets tab, you can switch off and switch on things, and we're going to create a string. Okay, so this is essentially the kind of string that you're going to have by clicking new string and just clicking essentially where your survey data is, snapping to those points and closing those strings. New string. I'm going to use a couple of tools that I will not explain at this point. So what I've done essentially is I've drawn these strings. So now I'm going to just put them in a position that is going to pretend to be maybe a pit. So minus 20 meters for that one. And then minus 10 meters for that one. So we say, okay. So we're going to make a DTM by clicking DTM. We'll say next. We'll use new strings. We say next. We say, okay, we won't use a boundary string, and finish. So this is the kind of data set that we will be drawing into Studio Survey. That's where the information that you're going to be looking at is coming from. So this is your typical, very crudely created open pit. That's how quickly you can do a digital terrain model. You can do all sorts of things with this. You can change the color and say, okay. You can also change whether this is transparent or translucent. Say, okay. So, well, there's nothing else to see here. So, or you can also change whether it's shiny or not, which I know Haja will be happy with. So you can very quickly change the attributes. You can change the attributes of that DTM, or you can also see the transparency that we set earlier. You can see through that. And this will represent a decent number of the data sets that we'll be drawing into our exercise for this afternoon. So I'm going to unload all of this. We haven't saved it. It's just an example of how some of these data sets have been created. So I'm going to go into my folder. My folder has been set up for 2 webinars, both for this week and next week. So please don't let this intimidate you. So first things first, what we're focusing on is the end of month survey. So what we have here, to give you a quick preview, is a surveyed pit surface. Eesh, it's a horrible color. So let's just close that and load it into the software by dragging and dropping. So that is named after the 1st of September 2019. And to avoid confusion later, I'm going to change that color like I showed you how to just now and make it less shiny. Haja, happiness, apply, okay. So we have this wireframe that we've got loaded. That's for the 19th of September, so the 1st of September 2019. We're also going to drag in the 1st of October 2019. So this is the surface that was mined the month after. So you can see that a bit of mining has taken place. Let's go ahead and do that transparency thing so that you can maybe see through this as well. Okay, there we go. So now you have yourself a nice indication of what we're going to be doing. Okay, maybe it's a bit too transparent, but let's, okay. The other data set that we're going to load in is the Pit Excavation Boundary. So you can see that that boundary has come in. There's that over there. Now, at the start of this, I promised you that we're going to split this into the north and south, okay? So we've already made our bench definitions. We've loaded a pit excavation boundary, and the final data set that we need to chuck in there is the initial topography. So the initial topo is your surface before you started mining. So here it comes. So that covers everything. Let's make this one transparent so that we're able to see through it and take a look at our data sets. So we say, okay. So we now have the data sets loaded that we will be using in the end of month calculation. So we've got your pit excavation boundary. We've got our September month, we've got our October month, and we've got our natural topography. Okay, so let's just re-maximize this page and get cooking. So for the sake of simplicity, I will now go ahead and hide that, yes. So the data is loaded. I've just basically switched off, for those of you that are AutoCAD and MicroStation users, this is the same as switching off a level or a layer. So just unchecking that will hide that data set so that you can focus on what you need to be looking at. So before we continue, let me switch those off and let's go to plan view. I will break this string into the two portions that we're going to say is the north and the one is the south. So we go to our string manipulation, which is on the edit tab. Under the break tool, you can either break at intersection or divide. So we're going to divide this outline into two. I was tempted to use the break with string because that would have given me so much more functionality, but okay. So what we've done by doing that is we've split that string into two individual strings. So the next thing I'm going to do is save that one. So we can then go save, single string, and then it's going to ask us. And I know that this one is the north. So I'm going to just put north in there and save that. I've named it a name that will be easy for me to post this to the database. And then we can then go ahead and save single string. And this one will be south. And then what I will do, since I've saved those two individual strings, I can hide the original one that I got this from or unload it completely because I won't need it anymore. And then load up the two new strings that I've got, which is my north string. Okay, we've got our north. And then I'm also going to load my south string. Okay, there's our south. So these two strings are now defining the boundaries that our calculations will be constrained to. So again, if we have a contractor in the north, the volumes that they are being mined will be measured within this string in the north. In the same way, if we have an activity or a contractor in the south, the volumes that they are measuring will be constrained to the string that we have created in the south. So this is our pit excavation boundary. So some of the operational uses that you might have for this is maybe this is ore and this is waste. You can split that into ore and waste using the boundary strings. Or you can split, like we've said, by contractors, or you can just split it into the block names that you're tracking with your equipment allocations and so on. In fact, while we are talking about the strings, let's add these same ones to the database. These will be the first data sets that we will add to the database. So we go to add to database, and then this dialog pops up. Our surveyor, Mr. Muniz, went over and surveyed this in the correct system, and he got us a boundary string for that. On which date you select the date, or you type in the date that was surveyed. So in this case, we accept today's date. The other thing that you need to be aware of is the current area. Which area are we going to define with the boundary string that we are adding? And then next is the type of data. So this dialog box will be used for adding every single data set from your survey to the database. So as you can see, is a list of every single type of, sorry? Sorry about that. I just got an indication that I had a disruption in my audio. Let me
I can
have
hear
Aaron.
you.
Okay, let me just ask Aaron. Aaron, can you hear? Did you get a break? Hello, Aaron. Okay, we've got quiet. So we have, yes, Haja?
Does anyone else have a problem with the audio? Because I can hear you perfectly.
Okay. Just a quick check. We've got Douglas. Douglas, can you hear us?
Can you hear us? Yes, perfectly.
All right, thank you for that. Aaron,
Yeah.
you've got sound?
Yes, Colombo, good from here.
All right, thanks. Okay. So at this point, we're going to we're going to post the data sets to the database, and we were going through the types of data that you can post to the data set. So to the database, sorry. So you've got your designed pit surfaces. Now these you will use in your design compliance. Your end of period pit surfaces. Now these are going to be the scheduled pit surfaces that will be created from NPV scheduler or whatever your scheduling package is, and in conjunction with Studio OP. And then you have your natural pit surface, which we loaded up. And in this case, the natural pit surface is the big red one, which we'll be uploading just now. We've got your pit blast volume surfaces. We'll get to those next week. Your excavation boundaries, which we're dealing with. And then you've got your ROM stockpiles and attributes, and then your surveyed pit surfaces. So for this exercise, we're going to deal with the natural pit surface, the boundaries, and the surveyed surfaces. So what we're pushing in are the pit excavation boundaries. The next window here is the current area. So under current area, you've got area, current pit, or global. So since this is only applying to the south of the pit, we'll say current area. Our data source, we shall select from the two strings that we have loaded, which is going to be the south, and you click add to database. And we'll do this again for the north side of the pit. So we switch over to north, we say, okay, we're still loading an excavation boundary. Maybe this was done by a different surveyor on the same day. Current area, data source, we'll say north, and we'll add that to the database. Okay, so we now have two strings loaded that are defining our operational areas in the pits. The next data set we will be loading, let me just close this for a second and then drag this so that we're able to see the full file names, and then you can follow as I'm pointing these out. So we go ahead and reactivate our database update. So what we're going to add is our natural pit surface, which is that file over there. Where does this apply? This could apply either to the current pit, especially in this case where we only have one pit active. But if we've got more than one pit and they are covered by this natural topography, we can then go and switch over to global. And then our data source will be natural surface, which is that one over there. And then we add to database. So by assigning certain facts to this, we say this was surveyed on that date. Aaron maybe went with a drone and did this survey over the entire mine license area and generated this surface from the LAS file. And we have ourselves a surface. And then finally, we're going to add the surveyed pit surfaces. So the scope for that will be the current pit. So once you've selected the scope as current pit, it doesn't matter what you've pushed in as the current area, because that is getting to the scope that is larger than that. So you don't really need to subdivide your definitions when you don't need to look at the subdivisions of your pit definitions when you're looking at that. So this applies to the current pit, and what we're going to upload is the September survey. So now that we're adding the September survey, in your case, you might just be adding a DTM like the one we created, and it doesn't have a date. But in this case, we're working with data that has already been processed. So you can then put in the date that that was surveyed. And since this was a very hard job, we sent in the big guns, and Kalumba went and surveyed that. And we add that to the database. Task successful. And then the following month, which was October, so we go ahead and change the date. This is very important. Usually the date will be the default of whatever day you're working in. So again, this was a ridiculously hard job to do. So we sent in some more big guns. We sent Aaron to do this, and we add that to the dataset, to the database. So I will just mention that it's very, very important to make sure that your dates are correct for the dataset that you're working with. By default, today's date is what will be in this window. What this simply means is you've come in from the field for that day and you've edited your strings and you've made a digital terrain model like what we did as an example earlier. So we're now ready to essentially run our reports tab for this. We say, okay. Now, I also need to mention, when you're doing this in your day-to-day operation, you will only add whatever this month's surface is. The previous surface would have been stored for you by the software in the database, and it will access that on your behalf. So in this case, we can go over to the reports tab and then go to Pit Actual and click Pit Actual. So again, we start. So in this case, since we've got the north area, under the north area, we might have a number of boundary strings, but there's only going to be the boundary string that was defined. And then you've got the surveyor that went out and or the one that's currently running the calculation. So that could be either of those people, either Aaron, myself, or Haja. And then the report date. So under natural pit surface, remember I said we've got two templates. So in there, what you push in is simply the pit surface that exists in the database, and that has been saved by date. So we pushed a natural pit surface in there today, and we get that today. And then for our surveyed pit surface, Studio Survey will go ahead and select for you sequentially which surveyed pit surfaces are available. So you will have any number of surfaces loaded, but it will pick the most recent one as well as the one prior to the most recent. Or you can go ahead and pick the one that is applicable to the process that you're carrying out. So one of these is maybe comparing a December pit surface against a January pit surface to get a calculated progressive volume for the mine. Sorry, that for some reason disappeared off my tongue. So here we go. So once these data sets have been selected, you can either take a look at them in the preview and just confirm that you've got the correct data selected. Just say, yes, that is the DTM of interest by clicking that eyeball so you can Google at your info. Or if you're like me, you want to see the data that you're working on as you're working on it. So you can load by clicking that arrow and you will see the data sets as they are. So once you've got that, you simply click calculate. So below calculate, we've got add to batch, but I'll get to that in a moment. So once we calculate, what's going on is the software is taking care of 3 different calculations. It's calculating the volume between the natural pit surface and the current pit surface, the volume between the natural pit surface and the previous pit surface. It's also calculating the volume between the previous pit surface and the current pit surface. And as I was talking, we got ourselves a notification to say that the task had been completed. So at this point, we've got results as at 14:45 Central African time. So to take a preview of your output, you can also click the same eyeball, or let's go OK, and then click the eyeball just to take a look. So this is the output for the northern area. If we go back to Studio Survey, you're going to see that we've been taking care of the northernmost bit. And then the other thing is this is taken care of by the boundary string. It gives you the surfaces, the dates that they were generated, the area, the mined volume, the surveyor that did this, and he will obviously have to print this and sign it before handing it over. And then you're also going to have the data mine table that is created where the report draws it from. But you don't need to look at this because this is arranged for you in a nice, neat report when you run the publish. So at this point, we'll go ahead and take care of the south as well. South, okay. And we'll change essentially nothing because the dates of what we loaded are the same, but the excavation boundary has changed because we're dealing with the southern area, and we'll run a calculation. Now, to talk about the batch process, if your data set is huge and there's bits that are massive and has a lot of triangles, sometimes you create this by flying a drone or things like that. So your drone will create a LAS file, which you're potentially going to disseminate into a much thinner, lighter data set, which you will then use to generate your topos, your your surveys, and that surface is going to take a bit longer. So if, for example, that process will take 15 minutes to do, and you'll get a feel for how long these processes will do, you have the option to add this to the batch process. Now we've already done the calculation and we've already got results, but I just want to show you what this looks like. So we'll just repeat this computation. You can then say, aha, the south, I am setting up this pit surface, this previous, this current, and this pit boundary, and I'm adding that to the batch. And you add that, and you say, okay. Without wasting time, you can go over and set up the next area that you want to do the calculation for. So for the north, you say, okay, you change your parameters and add that to the batch, and you say, okay. And once you've got your batch process set up and you click run batch, you're going to have everything that you've been doing set up already. Now, this is particularly useful where your operation has, say, 5 pits. Each pit has maybe 3 or 4 areas, and you're just setting that up, and then you say run everything. Now it's going to give me, I think, an error because you've already run these calculations and we've already got results stored. So it's going to ask me if I'm sure that I want to overwrite those. So it's going to give you a progress on where these things are. So at this point, your batch process then takes care of all your calculations for you while you've walked off to have your tea or whatever it is that you want to do in the 15 to 20 minutes that this process takes with your very, very huge data set. Now here comes the nice bit. You can also publish your report in the same manner. So we haven't done these. What we have taken care of is the end of month pit report. So you can either just go for the latest, or you can select a date of whatever report you want to reproduce. So if you want to query what was measured, say, 3 months ago, you simply click the drop down and click the date of interest and run your publish. You don't need to go through and do everything that the surveyors did, look for surfaces and so on. The software will take care of that for you. It makes life very, very easy and very simple. So we go ahead and click publish. And as an output, we now have ourselves, or let's click OK. We now have ourselves an Excel spreadsheet, or a series of Excel spreadsheets, by the way, that will have basically everything that is reported. So in this case, we have a report for the northern side of the pit, and that's our volume, that's our net volume, and by bench, that is our report. In addition to which, we've got the plot, and in addition to that, you've got the solids that you can then post to your geologists to do their interrogation against a block model or against whatever processes that you've got in place to see what needs to happen, or whether you to see your grades and so on. So that is running the end of month process. Now, I've just noticed that we're horribly behind time. I've taken a lot more time to go through this than anticipated. Do we have questions? Nikki, do you have a question?
I'm good. No
Oh,
questions.
your hand was up. All right. Okay, let's go to okay. So the next thing that we're going to do will essentially be very similar to what we've done already, except the data sets that we're going to be loading will be used in the design compliance. So we already have surveyed pit surfaces loaded. The only thing that we need is a design. So let's close that. Okay, let's close that. And let's pick a design from our folder. So, oops, sorry about that. We have the pit design. That's my points, and there's my digital terrain model. Let's just switch those off, and let's switch off the points. Okay, so we're going to change the color just so that you have a visual appreciation for what we're doing. So this is the design. Now the source of your design will be your mine design package. In our case, you're probably going to have generated this in Studio OP. And one way of integrating these two packages is every time your mining engineer generates a design, you post this design to the database folder that was created for you, or you probably have your own internal communication systems that you have. But the moment you receive this design, post it over to the database and make sure that the date is correct. So we're going to go ahead and add this data set to the database. So we go home, add to database, and what are we adding? We are adding a designed pit surface. Scope. This design is for the entirety of the pit. So the scope will be the current pit. If this had been maybe just an update, you would have probably just loaded that in for the area and updated your design wireframe and maybe even mentioned the scope to which that applies. But that again is entirely up to you. So here we select the file that we want to upload. So that's the pit design. We click that. So the surveyor that's adding this is the one that will take responsibility. So Hajar, since you're the mining engineer that does the most of the design, so we're going to put your name there and hold you accountable for this pit design that has been appended to the database. So the scope, the design pit surface and everything, are we happy? When was this designed? We can say this was designed in 2019. Oops. So we just go there and just type 19, January or whatever month. So let's call it maybe June, just type 6, first, and we're good to go. So you add that to the database. And that's it. So we're now ready to run the report where we're doing a design compliance. Okay, so to maybe make things a bit more interesting, we're going to add another pit excavation. No, let's not do that. I wanted to get the whole thing, but they're going to have the same date, or yeah, you know what, we can do that. I want to do the whole bottom of the pit in terms of the analysis. So we go ahead and get ourselves a pit excavation boundary, drag and drop. There we go. We're also going to add that to our database. So go home, add to database. And then what are we adding? We're adding a pit excavation boundary. And this applies to the entire pit. So the data source will then be pit excavation boundary. But just so that we avoid confusion with the other one, we'll say this one was put in on the 13th. So when we come to do our analysis, we'll pick the boundary from the 13th and we add that to the database. There we go. So we can go ahead and run a design compliance report. So the excavation boundary that we're selecting is the 13th. At this point, we are going to do an analysis for the whole pit. So the current area displayed there doesn't matter. And Haja is doing the analysis because she wants to see how this compares against her design. And you run calculate. Okay, so we have our task completed successfully. And you can also preview your result, or you can simply run the report. So we have a print available in PDF, like we said at the beginning of this demo. We also have the solids. Now, in this case, we haven't split the design to go to the bottom. Our primary concern would be how the benches have been mined, whether our bench widths are correct, and look at areas like that that have either been undercut or overcut to go and identify the problem areas that need to be corrected. So you can go ahead from this point and run publish. So you can publish that report. So in publishing the report, this is something that we could have done together with the end of month. And what we're going to do now is also do a compliance to plan. So the compliance to plan, let's see if we have a schedule surface in our folder. Schedule, excellent. So that's our planned mining for the month. And we're going to add that data set to the database. So we go home, add to database. What are we adding? We're adding an end of period surface. So this end of period surface will have been generated from your scheduling package, from your design package. And this will definitely be your projection of what you intend to achieve by a certain date. So we're going to push in a date there of the date at which we added it, which in this case is today's date. End of period surface, the scope is the current pit, and you add that to the database. So we're going to get our scheduled surfaces. There we go, pit schedule, and add that to the database. Woo! Just restarting. I must have done something really dumb just now. Let me restart the package and so that we can see what we can do. Do we have questions at this point, by the way?
If anyone has a question, he can raise his hand and we can unmute him.
Mona Lisa. Mosier Kambala. Let's take a question from Mosier. How do you pronounce this, Haja?
I don't know. Moise, I think.
I'm failing to unmute him or her.
Okay. So he's self-muted.
Okay, so we don't have um, any questions. So we go ahead and open the project. We didn't. Oh, wow. This is actually a good opportunity to actually explain something. When we started out, we made the mistake of not saving the project after defining the database. So we'll go ahead and go to the database, see database webinar 2, and select the database. We say OK. We've already initialized, we've already added info to the database, and we say OK. So it's very important that you actually save your project as soon as you do that, because once you do that, it will not it won't ask you to remap the database location. Nikki, thank you for that suggestion of adding a legend. So one of the explanations for doing that is that we ship Studio Survey with just the generic plot settings. So you have the option to add things or subtract things depending on what you want. This is entirely up to you. So what we just have is a plot that meets, I think, for lack of a better term, the absolute minimum requirements of an operation. I hope that takes care of that suggestion. So yes, you can add a legend and you can have it in place. So yeah, you can definitely do that. Okay, so continuing from where we left off. We were loading, let's just see if we've got the scheduled surface loaded by going over and running up. Ooh, so we added this, eh? Cool, so we've got the as-built survey. And then just to confirm before our software rudely interrupted our session, we managed to upload that to the database as well. So the pit excavation boundaries for the whole pit. So this is where we're going to now look at running these things via the batch process. So you can have your pit actual, set it up with a boundary and a surveyor, as well as everything, and then add that to the batch, say okay. You go to your design compliance, you select the boundary that you're working with and the surfaces that you want to compare, the surveyed pit surface and the design. You add that to the batch, say okay. And then you have the plan compliance tool, the boundary, and then add that to the batch. So what this does is it saves you the time that each individual process takes to run before you move over to the next tool and perform your calculation. So, oh, sorry, I clicked calculate instead of running the batch process. My bad. So we've got these batch processes in waiting. We can then say run all, and then you'll see the progress report of each of those. So this is the point. You go get your mug, a bit of sugar, some coffee, make yourself a cup of tea, and you do something else. Sign off your blasting tabs or your blast designs while the software is taking care of this process. So we are 5 minutes over plan. And do we have questions in the question bar? We do not. Okay, so all of the processes that we set up have succeeded. So you're now at liberty to publish a report that consists of everything except for our stockpiles and our blasts. So we have our end of pit, our compliance to design, compliance to plan, publish. It already exists. Do we want to overwrite it? Yes. This is simply because we already had something earlier. So to avoid overwriting that, let's put in a different date and publish. Okay, so we now have ourselves a report very similar to the first one, but in this case, we don't have any volumes under the stockpiles, but we do have the overmine, the underbreak and overbreak, and the net differences of what was mined. We have the pit that this applies to, as well as the compliance to plan. We have the pit volumes that we've mined, and in addition to this, we've got a summary of the mined volumes. And then also we have a cover page. So generally speaking, when you print this out, this will be the first thing, and then you have all of these other reports coming as part and parcel of the report. The other thing that you might be interested to know is under publications in your database location, that's where you'll find the permanent residence of the various reports that you've generated. So you might be interested in maybe emailing historic reports. You will come to your database and go under publications, and you'll find all the Excel spreadsheets that you have created historically. So this will create a folder and save your Excel file for any reports that you create. And then as for the digital terrain models and your mining solids, your mined solids, you're going to find those in the areas under the reports. So under there, you find whatever was done. So we've actually run during the course of this webinar a couple of times. So we've got the plot that has everything, and the surveyor, the volume that was mined. We can close that. Can also close that. Can also close that. Ooh, we've done a lot, eh? And then you can have a preview of the various solids that were generated. So this is the difference. This is this volume that was mined, showing you your overbreak and underbreak, your comparison between your previous to current. So all of these are saved in the database as your mining goes. You don't need to actually come and look here. I'm just showing you this for your own interest. The software will keep track of where each and every one of these files is located, and you simply need to use the various dialog boxes to display or run these. So I believe we don't have any questions. If we do, we will use the next 1 minute to open up for a question. Do we have an audio question?
Apparently no. No, yes.
Okay. All right. So thank you very much for attending this session. If you go to the bottom of your dialog box, you will find a handout, which is essentially last week's presentation. And then this, we will be looking at the stockpiles because those take quite a bit of setup as well. We'll be looking at the blast volume calculator. And then whatever questions that you have between now and then, feel free to send me an email. And I would also ask if you could connect with me on LinkedIn because I tend to post quite a lot of this material. I'm looking through if we have a question. Kambala Malu Dame. Okay, you're self-muted, so we can't really get your audio. So thank you very much for coming for this webinar.
Thank you, everyone.
Thank you.